Hello everyone. So this session, let's go to the normal distribution. Normal distribution is a very famous distribution with a very standard graph. We call that bell curve graph. Normal distribution here is calculated the possibility of the curve or the all element and that curve. Okay. So let's first go to see the normal density function. Fx equals to 1 over square root of what? 2 pi times sigma. Sigma is what? Standard what? Standard deviation, right? Standard deviation is what? Square root of variance, right? And the times e to the -1/2 and then x minus mu. Mu is what? Mean, right? Then divided by standard deviation, sigma, and then to the second power. So this is a formula, normal density function. You think about what is called density, right? So density is like a probability, right? It's like probability, right? Probability. How many in one area, right? It's like this way. So we have a simplified version we call standard normal distribution. Standard normal distribution is when mu equals to 0 and sigma equals to 1. And how this looks like, it will be like this way, right? Because mu is already equal to 0, so this one it looks quite simple, right? And normal distribution have a very beautiful graph, so and it's very special. So let's see the graph. So you see here now. This graph is for standard. Okay, if not standard, the curve is never changed. You just go to different kind of place. Okay, it's not exactly on the center of coordinate. Okay, so I'm writing I joining the several horizontal. No, sorry, this is not horizontal. Vertical line. Okay, you can see this line. This line is the what? This line is the standard distribution, right? Standard function, that's the function, normal standard function, and it's very smoothly and very symmetrically on both sides based on the y-axis, right? And you also can observe that when it's go to if you go to maximum to the right side or to the left side, it will be very less portion, right? Probability there. So which means that there's very less opportunity for a value, and the least probability density function will be after 3, negative 3, or what? After positive 3, right? So they're very less. You can see what we will see. You see the area. You see the area, the curve, and the x horizontal. They form this kind of area, right? So the area will become very small after negative 3. Will become very small after positive 3. Am I right? That area is exactly pressed as the density. Okay, density. So here is their speciality. So for the first standard 1 and -1 deviation of the mean, it's not almost exactly 68% of all the value is in this area. It's very special, right? And for the second deviation of the mean is 95% of value all in this area. So almost they're all in this area. If including the 3 is 93 standard deviation is 99.7 all in this area. After this, it's very less. In another kind of way of thinking, if it is after 3 like 4, when x equal to 4, they have very tiny chance to have a value to happen there, right? You think about, we are learning statistics, you think about what's the probability that's within the 1. to 0 or 1 to -1, right? It's very high, 68%, right? If you said what's the probability of the 4 or 5, I think even the whole area after 3 is only 0.03. So whatever you are just looking for, that 0.03 percentage, so it's very low, right? Of course, if you want to make it very detailed, around 4 to 5, or that will be very, very, very tiny. Okay. So then we go to another very famous concept that you need to learn is that probability density function. So you think about the normal distribution is a probability density function, right? So what's the probability density function? The formula looks like this one. Suppose this should be not B and A, but is what? Maximum and the negative maximum, right? So fx here is exactly the here, right? The formula is here, right? So this is fx. So this fx in fact is probability density function. But if you want to calculate the probability in a special area within A and B, you should write it as this way. Okay, so this should be fx. What is fx? Fx, you think about that. Fx over x is the pre-derivative. If fx derivative is will become to the small fx. This fx we call continuous random, the CMD, right? CMD. Okay, CMD. Okay, they have two characteristics. Very important. If you don't meet these two characters, it is not a probability density function. One is fx have to be greater than 0. Think about this called about the probability density. The lowest probability is 0, right? And never you heard someone say the probability is -1. It's okay when you just tell story about exaggeration, it can be like the way, but in scenario, no, right? The second one, since the probability, the whole probability of the whole area, the whole unit that you want to test, it should be 100% is the biggest one, right? So the density function, if from maximum to the negative maximum, it should be 1. That's the two standard. If you don't meet this one, it's not probability density function. You cannot find the probability based on that so-called function. Okay. Then I will give you an example here to make you more familiar with that. Example is a continuous random variable with a PDF. P is one. PDF probability density function is this one. And the time when x are greater or equal than 1. When x less than 1, fx equals 0. When x equals 0, what that means there's no chance, right? No probability, no density there after the less than 1, right? So, or in another thinking is that all the probability, all the values lying on when x greater than 1 to the maximum can be think about that way, right? So they first ask you to find the value a, and then second ask you to find the probability between when x equal to 1 to 3. Okay, let's solve it one by one. Okay, so for the first one, find the value a, we have to use the second standard, the characteristic. So let's just write in as negative, and this should be fx dx equals to 1. Am I right? We just copy paste, there's nothing wrong. So let's think about that. For this one is this special, the negative, maximum negative, they should be here, it should be 1, right? Why 1? Because below 1 is already 0, so no make sense, we need to calculate 0, right? So it should be like this way, 1. So fx is equal to what? 4a minus 1, and then below is x to the cube, x cubed, right? And dx, right? Equals to 1. So what's the result about this one? The result will be what? This is x to -3, right? So x to -3, if original one is x to -2, am I right? X -2 derivative is -2 put in front, right? And if you want put in front -2, they So here it should be negative 2. So make this like after derivative is x to the negative 3, right? And for this one, 4a minus 1, since it's a constant, so you just copy paste, am I right? So 4a minus 1, so that's it, right? Am I right? I think I'm right, right? So and this one should be right. As well writing this one, right? So what's that? It should be negative 2, am I right? A minus 1, am I right? Oh no, I'm wrong. You just copy that, 4a minus 1 negative 2, okay? So because they are the same, so inside is what? So inside will be x what? Negative 2. What? When x is what? When x equals to maximum, right? Minus what? X negative 2 when x equals to 1. Am I right? Then let's see. This one, maximum and square over 1 minus the right side is what? 1 over 1, right? 1 square is next to 1. So this is 1 will be what? 0, right? This one, if below denominator is the maximum. So if one number divided maximum, of course, is the smallest number is equal to 0. That's called limitation. Okay, limitation equal to 0. So 0 minus 1, so it's negative 1. So negative 1 times this one will be positive, right? So we can write in as 4a minus 1 divided by 2 equals to 1. Here already here is 1, so it's to 1. So a equals to what? This will be 2 go to another side, so 3. So 3 over 4. So this is a, right? So since you already know a, so this probability density function we can write here like this way, okay? So for a is 3 over 4, so this 3 times 1 so it should be 2, right? So 2 over x3, so fx equals to, right? What the condition is x greater than equal than 1, right? This is probability density is one part, right? Another one part is what? Fx equal to 0, right? The proportion, right? When x less than 1, right? So it's proportion. Okay, so next one I ask you to find the what? The probability when x in 1 and 3. So of course we will not use the second one, right? Because it's already less than 1. So 1 and 3 only in this part, right? So remember the formula, right? So here is right 1 and 3, right? And this is fx, right? And this is dx. Am I right? So this will be what? This will be what? First you have to be find the fx, big fx first, right? Big fx is what? Big fx, in fact, we already know, right? Big fx is as x minus 2, right? X minus 2, and there will be provided 2, and there is 1/2. Let me see like this way. And here is already have 2. You just copy here, right? So this will be the fx, right? So we just writing 1, 3, right? So this will be just negative 1. So negative negative 2. So this x equal to 3 minus what? Minus what? Negative, right? X equal to 1, negative 2. Am I right? So this will be the probability function. So this will be what? This will be negative 1 over 9. So this will be negative, that will be positive, right? And definitely this will be 1, right? So this will be what? 8 over 9. 8 over 9 is a percentage, right? If you count here, 8 over 9 is about what? It's almost 90%, right? It's almost 90%, right? So you think about that. So for this density function, so for this probability density function, when it lies, the value lies between 1 to 3, they almost occupy the 90% for all the values there. So it's a very high density, right, in that sort of area. Okay, so let's use it when you are learning about the probability density function, uh, because we have many model there, right? Like normal distribution, like exponential distribution, right? So many of our statistics they can fit for this kind of model. So this provide a way for you to calculate the density, the calculate the possibility of an event will be happen. So that's the value of learning this. Okay. So thank you very much to go with me to review this session and hope you really learn something. Okay. Thank you very much and have a nice day. Bye bye.